Hi, welcome to this new video. I'm Sergio, I'm the founder of PySource, where we build computer vision solutions to help companies improve their process efficiency, reliability, and scalability. We're going to talk today about hardware setup, how to choose the right setup for a computer vision solution. Hardware setup is a very important process of the design of a computer vision system in order to get the right performance. Because the wrong setup, either undersized setup, will give poor performance where the project might not work properly, or on the other side, an oversized setup will give you all the performance you need, even more than you need. But the problem is that when you try to scale that solutions, for example, with systems that need 20, 30, 50, 100 multiple cameras at the same time, then having an not optimized software and oversized setup will have a huge impact in terms of cost and resources that the company need to allocate to keep the computer vision solutions working. So in this video, we're going to discuss about three things. We're going to discuss about hardware, the components that you need for a proper hardware setup for a computer vision solution. We'll discuss about hardware optimization, how to optimize, why it's important to optimize that. And also I will talk about some examples from real experience coaching some companies that did some big mistake with the wrong setup, and that's why they were not getting the right performance for the solution. And later at the end of this video, I'm also going to show you some benchmark. Especially I want to show the benchmarks running on my machine to see how the same hardware with different tuning and different optimizations will have a big impact from the low optimization to the maximum optimization. I want to show you that there is a huge difference between that. Let's start with the hardware setup. So hardware. Okay, I will keep this short. Hardware setup. I will start saying this, that hardware setup is part of the designing of a computer vision solution. So I can only give you some guidelines, but I can't give exact benchmarks and exact models or graphic cards or CPU and so on that you need. First of all, we start from the task that we need. We need to identify objects, identify objects. We need to classify. So identify objects, for example, I work with vehicle traffic monitoring companies where we do a lot of identification of vehicles. So this is a task where we need to identify objects. That's an example. Classification, for example, in the manufacturing industry is taking picture of product and just classify these images for identifying defects, identifying if they belong to a certain category, and so on. Or more complex tasks like segmentation task. Segmentation, where you do not only want to get the position of the object, but also you want to segment the exact object. For example, applications like there are many online where you put your picture and they remove the background. That's a more complex task because it's segmentation, and we have many other tasks like person identification, for example, facial recognition, person identification, even heavier tasks than all these previous three. So this is a first start to understanding the setup, where classification is the smallest computational power required task. Identification is the second, object detection is the second. Segmentation is heavier. Facial recognition, person identification is a heavier task. This is just to start. I know that there is a lot of information now, but I want to give you some guidelines. And if you have some companies that want to implement this, if you have questions, please let me know the questions down below in the comments. I will try to give you some info with that. So once we know the task, then we need to know the scale of our task. How many cameras? Cameras plus number. For example, when we work with vehicle monitoring or people counting software, usually there are a lot of CCTV cameras placed in different locations that companies like traffic survey company have, city councils have, and so on. So the number of the cameras is very important because each single camera is an extra task that we need to handle. For example, if we have 2 cameras, we can have a small setup. If we have 20 cameras, then we need much bigger setup. That's very obvious, but it's good to point that out. Some information about the hardware that is necessary for computer vision, which is that one where I want to get. Now let's get more about the hardware. There are two main components that are very important. Is the CPU, the processor of the computer, and the GPU. And it's very important that this hardware is properly designed. The GPU, let's say, it's one of the most important for our computer vision solutions, because the GPU is the one that will handle the heavy tasks of identifying the vehicles, identifying the objects, classifying the images, and so on. So the GPU has always the heavy task on our system, but at the same time, the CPU needs to handle all the rest of the solution, because if you have an oversized CPU, then oversized CPU, I mean, it's okay, but it's a waste of resources. You spend a lot of the CPU, and then you use your graphic card to 100%, but your CPU is only used 20-30%, and it's a waste of resources when you buy a computer vision solution, when you buy a server, or when you rent a server. If you have a very powerful graphic card, like we have for computers, personal computer, we have like the RTX 4090, and I'm going to give you this example because when I coached some clients, they were building a solution, I saw this mistake. So they had, I don't remember the graphic card, it was some server graphic card, very powerful graphic card with 24 gigabytes of memory and thousands of CUDA cores, probably RTX 4090 or some server solution. And then they had a very bad CPU, very old CPU, 10 years old CPU, just dual core CPU. They wanted to elaborate a frame stream of only 4 cameras at the same time. So the solution was a system that could elaborate 4 cameras in real time, 1, 2, 3, 4, with 30 frames per second each camera. Achieving this result with the graphic card RTX 4090, which is one of the now most powerful computer vision graphic cards for personal computer. Of course, servers have also more powerful solution, but now to keep things simple, I'm going to use these personal computer examples. This graphic card can easily handle this task and can have many more cameras at the same time, but they were struggling to reach using this card. I don't remember the number, but were 20. It was lagging, it was struggling a lot to get a good performance. We analyzed the code. The program was, for what I saw, was well developed. All the tasks were properly split. And then we analyzed the benchmarks. When we analyzed the benchmark, we saw that the CPU usage was 100%. Graphic card usage was only 10 to 15%. This because the system was not properly designed, so the CPU, which was a very old CPU, was getting 100% and was not fast enough to feed the data to the graphic card. So in that case, a small change by putting the proper CPU make the project work, but only this small problem, which is not so small, was stopping them to go further because the software wasn't getting enough performance for their solution. So why is this important? As I said at the beginning, 1, undersized hardware equals to not performance. Not the best English to say this, but it gives you the idea. And second, oversized, it's waste of resources. And the impact is very big because if you think about it, like renting a server online, even the smallest, like some simple server with only one graphic card, will cost from the cheapest companies at least $500, $600 US. With other companies, prices start from at least $1,000 just for renting a single server for 1 month. So if you have that oversight, then in the long run, it's a huge waste of resources. But there is another thing that we need to talk about, and it's hardware optimization. And this is also extremely important where we're talking about hardware setup and waste of resources, because ideally a good system solutions will be designed to use the least amount of resources. So if a solution that on a same machine that you're using for only 4 cameras, if the same solution is optimized and you can run on the same machine 20, 25 cameras, then the impact that you can have, it's huge on the company, it's huge on the resources that you will save, because there is the cost of the renting the servers, the machine, and also the cost of the infrastructure, because it's not only related to having more power, but it's also a more complex infrastructure if you need to get more power. So there are a lot of costs and problems, maintenance needed that get from that. And what I want to show you is now some benchmarks and the difference that you can get on a solution that is not optimized and a solution that is optimized. But before getting into that, I'm going to give you some guidelines on how we can do the optimizations. There are different types of optimizations, starting from the camera and the video feed. Let's say now, to make things simple, we're working on a CCTV camera, pay people, vehicle counter. And our goal is to process 20 cameras. So we have 20 cameras. We start first of all to understand what are our needs. So each camera normally can give a video feed with these specs. We have a resolution. Resolution can be normally either Full HD 1920 by 1080, can be 720p, smaller resolution, bigger resolution 4K, even if it's not common for CCTV camera, such huge solution, but there is also that option, or even smaller resolution 480p and so on. Another thing that we get is FPS, which are the frames per second. So normally either we get 30 FPS, which is a good standard to have from the CCTV cameras, or older cameras will give even lower frame rate, like 25 frames, 15 frames, and so on. This is something that we can already work on. When we work with computer vision solutions, we need to get the most result with the least amount of resources. Now, to understand this better, let me open this. This is now a solution of 720p. So this is a screenshot I take from a video. This is 720p. So this is HD resolution. But what do we have in this? If we are working with this camera has a certain complexity, because if we want to track vehicle from this view, we are tracking 1, 2, 3, 4, 5, 6, 7, 8, 9 lanes. So we have 9 lanes that we want to identify from a single camera. If we try to reduce the resolution of this camera, instead of 720p, we can get smaller resolution. We can, of course, process smaller resolution much faster, but we need to take into account that each time we make the resolution smaller, also the accuracy drops. So it's always about studying each single project. And also this one is important because when I get asked, well, I have 20 cameras, 30 cameras, what hardware do I need? We can't say right away before diving deeper into the project and analyzing each single camera. So after analyzing the camera, then we can start studying and finding the right benchmarks and hardware that you need for that. If we have 9 lanes, it's different from a view that has only 1 lane. Because if you focus only on 1 lane, you can have a very small resolution, like half or 1/4 of this resolution to get the same accuracy. So it's important to understand, find a compromise. The more information you need to find, the higher the resolution needs to be. If you want to count people, also it's important the angle of the camera. If the camera is top view, so it's top and sees directly at the bottom, which is the easiest to count people, then, and from that view you can only detect 2 or 3 people. It's different to having a camera that it's not ideal, it's tilted, it can see from the same view up to 80 people and so on. So everything needs to be tailored to your specific application. In addition to the cameras, what do we have? We have the deep learning model. And deep learning model works similar to the camera resolution, because deep learning, we need to give an image with a certain resolution. So if you give a bigger resolution, as we were discussing from the camera, so this, if we take a big resolution from the camera, also the deep learning model has more to process. But also, we have different types of deep learning model. Deep learning model have different sizes. We have usually nano version, medium, and bigger version. So what's the difference? The nano version is very fast, lower accuracy. Bigger version is very accurate, but much slower. So also these, based on the project always, we need to understand what model do we need. Of course, ideally we opt for having the smallest model as possible. Not always it's possible to have the smallest model. So that's why it's good to optimize that. And then in addition to this, what's the complexity of the task? So we discussed this a bit about the beginning, explaining the different tasks that we can do with computer vision, deep learning, whether you want to only classify, identify things, find a segment, so more advanced identification is even more advanced project, you want to do facial recognition, personal identification, and so on. In the example of the cameras, CCTV cameras to detect vehicle and people, for example, is it only day? So in this case, when the vehicle are most visible, or only also needs to process also at night? What are the weather conditions? Does this need to be activated outdoor in any weather condition? Any weather, or is this indoor? So we have control light environment. And let me now show you some benchmarks on this video right here. As I said at the beginning, the goal of this benchmark is to show you the difference from a non-optimized solution versus an optimized solution, to give you an idea of the gap that you can get and the incredible difference that there is in the hardware usage. So this is the video that we're going to use. This solution now is going to be very simple. We're going to identify the vehicles that are crossing right here in real time. So I'm going now to run the software that I have with just some basic code taken online that is not optimized. So now I'm running this. This is now processing in real time. My setup is now a graphic card RTX 4090. If you have an idea, like if you're experienced about graphic card and you know them, and a Ryzen 5600 CPU. What we're getting now is 60 frames per second on this video. If I run the task manager to see the performances that and resources that I'm using, we can notice that the graphic card usage is 84%. Some part of the graphic card might be used now by the recording software, but most of the graphic card is used by this solution, which is huge. Such a powerful card wasted mostly on just a single video. So, and getting only 60 frames per second. Let me try now to run two videos and see what performance I get with this. Okay, now the video is just starting. And if you notice, like when I stopped, like the previous video, there was a huge drop in the usage of the graphic card because most of it's used by this software. Now, as you can see, we are getting 45 frames per second per each of them. So of course, the more video we put here, then the lower the frame rate goes. This means that without any optimization, now if I go and put 4 or 5 of them, I'm going to have such a low frame rate that it's not even usable. Oh, I'm now running this solution on 4 frames at the same time. So we're simulating 4 cameras at the same time. Let's see now the frame rate that I'm getting right here. As you see, it's very low now. It's definitely lower probably than the original speed of the video. So it takes some time for the frame to update, but one went to 30 frames per second because it's the main window. So Windows is assigning more resources to this main window, but generally we're getting only a bit more than 20 frames per second. So software is not optimized, but also hardware is not optimized. If you see, the CPU is 100% usage. Of course, this is not the right CPU for such tasks. And the graphic card is only 50% used. So we're not able to leverage properly the graphic card with this system right here. In addition to this, also, the deep learning model is not optimized, so it's taking a lot of resources and giving no good performance. Now, I could take now the optimization level too many steps, shrink the image, improving the deep learning. I don't want now to make this video too long, otherwise I could show you step by step on if we drop the frame, the resolution, okay, we improve a few frames. If we change the deep learning model to a smaller one, we improve a few frames. If we change on the code to leverage more cores, we get more frames and so on. I don't want to go through all the technical specs, so I'm now going to show you like a very optimized model and what frames and performance we can get from that. So I'm now running very super optimized solutions, and even doubling the number of streams, we have like huge frames per second. So we're processing much faster than we need. Normally we will need just 30 frames per second. Now we have 8 at the same time instead of 4. So we not only double, but much more, we increase the performance. At the same time, we are not leveraging the graphic card that much, only 37–40%. Of course, the CPU, this is just for example, we're using the CPU 100% because it's not ideal for this type of setup. But you can get the idea that now we getting the right hardware, optimizing the software, we can process a big amount of frame from a big amount of cameras from a single machine. This means much lower cost and better performance when you implement this solution in your company. I hope this video was clear. I know that I put a lot of things about each thing, but there was a lot I want to talk about, and I might go in other videos more in depth each single aspect. Please let me know if you have any questions down below in the comment. If you have a company and you want to implement such solutions, feel free to contact us at PySource.com. All the links are down below in the description. This is also for this video. See you in the next one.